For DS2, we retained the URLs of each link that was contained in the page, as well as the source and destination URL for each HTTP redirect that we followed. And since we hadn't retained pages, we had to inspect current versions of these URLs to try and determine whether or not they were spam. And out of a random sample of 1,000 pages, 465 of them could not be downloaded or contain no text, and 6.9% of the remainder were spam. That statistic has a confidence interval of 2.2. The first property we looked at was the URL itself, as I mentioned. So you might expect, as we did, that a dynamic site that was kind of built with a deep tree would have, as I mentioned, kind of long URL paths. However, we didn't find any correlation between any properties of the complete URL and spam. However, when we applied the same technique to just the host component of the URL, we actually did find that correlation. And so synthetic host names do look different. They're longer, they have more dots in them, more dashes, and more digits. This is easy for a site to accomplish because, as you may be aware, you can create a wildcard DNS record. So any record that doesn't have a more specific pointer can be resolved to a specific address. As an example, at the time the slide was created, the highriskmortgage.com domain, if you tried to look up any host name in that, it would resolve to 65.83.94.42. And the reason that sites do this is there's a piece of SEO folklore that says that if a component of your host name exists as one of the query terms, then your result will be ranked higher. And so they try and game the system. As you can see, there's 4 example host names there that are very long. And in 3 of them, it's easy to see what query that particular host name is trying to game. There's also a graph that shows you the histogram of the host name length in characters for all the hosts that were in DS2. And the blue box identifies the hosts that we've identified as potential spam candidates. And that's a convention that will be used in the remainder of the slide. So this technique flags 0.17% of all pages in our collection as spam. A side effect of SEOs creating all of these host names that point to a single IP address is we can look at how many host names resolve to a particular IP address as an indicator of spam. This graph shows you the histogram of the number of host names that map to a single IP address. And if you look in the far right corner, you can see that there's nearly 9 million host names that map to that one particular IP address. And in this case, they've taken words from the Italian dictionary and created host names for them. And if you try and connect to any of those host names, you will just get a redirect back to their main domain. So this technique is extremely effective. It flags 3.46% of all pages in our collection as spam. However, it also has a high false positive rate, which comes from sites, typically blog sites and things like that, where you create a separate host name for every user that has an account on the system in order to shorten the URL length. You can mitigate this with a short whitelist of known good sites. There's another piece of SEO folklore that says that a remote link should be valued more than a local link. And this makes sense if you think about the endorsement power that links have. If a site links to some other site, it says more about the other site than if that same site linked to itself. So in order to try and flag pages that have many links that appear to be remote but are actually local once you have performed DNS resolution, we define the host machine ratio metric, where we define the host machine ratio of a particular page P to be the size of the set of host names referred to by links in that page divided by the size of the set of distinct IP addresses that those host names resolve to. And then compute the host machine ratio of the machine is the average host machine ratio of all of the pages that are served by that machine. And we found that machines that have high host machine ratios are very likely to be spam sites. Again, this plot shows you the average host machine ratio for all the machines in our data set. And the blue rectangle identifies those of which that are spam candidates. So this technique flags 1.69% of all pages as spam. Looking a little deeper at the link structure, we plot the in-degree and out-degree distributions. As previous work has shown, these distributions are Zipfians, and the outliers are predominantly spam. So in the upper plot, which is a plot of the in-degree, if you see the point that the arrow is indicating, that's the point that has in-degree 1001. That has about 185 times as many URLs that have exactly that in-degree as the distribution suggests that it should, which is fairly clearly spam. And there's some sample URLs from that in-degree. If you look at the lower plot, which shows you the out-degree, it's not, the outlier that's indicated by the red arrow is not as significant. It only has 100 times as many URLs as are indicated that it should have by the distribution. And as a matter of fact, out of the URLs, all of the ones that are not expected by the exactly the number that's not expected by the distribution comes from one particular domain, which again is a clear indicator that this is a spam site. So the in-degree technique flags 0.2% of all pages in our collection as spam, while the out-degree technique flags 0.05%. Looking at the syntactic content, such as the number of non-markup words or the content length in bytes, we observe that normal websites have a variety of pages on them. And so the size and word count distributions are typically Gaussian, and they have a non-zero variance. However, some spam sites generate very templatic pages, often where they've taken a particular block of text and stomped 2 keywords and a link down at kind of predetermined offsets within a page. And these sites show near zero variance in size and word count distributions. So the exception to this actually turns out to be something called soft error pages. A soft error page is a page that's returned with an HTTP result code of 200, which means OK. But it actually, the text on the page indicates that it should have had some other return code, such as a 401, or you're not authorized to view this page, or a 404, document not found. I'm sure everyone has gone to a site and seen a page that says, this document couldn't be found. Please start over at our homepage or search for it. These pages are also not useful for a search engine to include because they only contain this error message. And a good example of this is the site www.protein.com, which contains protein sequence information that various scientists deep link into all of the time. However, if you're not a subscriber, all you get back is a login page, whereas if you are a subscriber, you get the actual sequence data. So this technique flags 0.21% of all pages in our collection as spam. As I mentioned at the beginning, the reason we began this investigation was because we found a site in Germany where the pages were evolving too fast. So as it turns out, there's many other spam sites that are generating web pages on the fly, and the content that's returned may not have any relation to the URL that's requested. So if you request the same URL multiple times, you will get different content each time. And a search engine can detect this by measuring page evolution. So this plot shows you the average number of matching features per document from one week to the next, where 0 on the right-hand side means the document completely changed, and 84, which is the maximum value on the left-hand side, means there was no detected text change. It's a probabilistic sampling method, so there is a slight chance that there was actually a change that just wasn't detected. And as you can see, for the majority of IP addresses, most pages don't undergo significant change. However, if you look in the blue band on the right, you can see that there are a number of IP addresses where every document, on average, undergoes complete change from week to week. And in fact, I've drawn an orange circle around the IP address in the far upper right that was the German spammer I mentioned at the beginning. You might think that sites such as news sites or discussion groups would actually be identified